As you probably know, Apple recently launched the iPhone Air MagSafe Battery with its new iPhone series. It gives your iPhone Air 65% extra charge. That's not very impressive for 99 bucks. And unfortunately, it doesn't work with other iPhones. In this video, I'll show you how to build your own 10,000 mAh MagSafe power bank that supports 15W wireless fast charging and twin 2.5 USB-C fast charging. Plus, you can attach it to any iPhone or other smartphones and accessories. So let's build this MagSafe power bank, test it, and see how much it actually costs. Since we are building a power bank with a wireless charger, let's quickly see how a wireless charger works. Inside every one of them, there is a coil of copper wire placed on a small freight sheet. And your phone has a thin matching coil like this one. The charger circuit sends alternating current through its coil, creating a magnetic field. Your phone's coil picks up that energy and converts it into power to charge the battery. There are a few wireless charging modules we could use, like this 15W fast charging with USB-C input, perfect for our build. Next, we need rechargeable batteries. Lithium-ion cells, such as the 18650, are common, but they are usually bulky and round. Another option is lithium polymer batteries. They are flat and available in many different sizes. That's why I choose this 5000 mAh LiPo battery. It keeps the power bank slim. The battery code shows its size: 9.5mm thick, 55mm wide, and 65mm long. I picked up two of them to make a 10,000 mAh battery pack. Now we got the batteries and the wireless charger. The idea might sound simple, just hook them up with a USB-C breakout port like this, and you've got a power bank. But wait a second, that's not possible. See, batteries give us about 3.7 volts, while USB-C needs at least 5 volts. So we have to boost the voltage. On top of that, we need the proper way to charge the batteries and keep them in a safe voltage range during charging and discharging to prevent damage. That's where power bank modules come in. They handle everything we need on a tiny board. This one is the LXLBC 3.1. On paper, it looks promising. It supports 15 watts output, which is exactly what we need. So I hook it up to the wireless charger and run a test. It starts charging, but then I notice a problem. The charger doesn't switch into fast charging mode. To double check, I connect my phone's adapter directly to the module. And yes, it shows fast charging. So why doesn't the wireless charger go into fast mode? It's simple. Even though this module can provide 15 watts, it only does so at 5 volts. But according to the wireless charger specs, it needs 9 or 12 volts to active fast charging. That's why the LXLBC 3.1 falls short for this build. So I had to get a new one. A tiny twin 2.5 watt power bank module that supports PD3. According to its specs, it provides the voltage required for fast charging, and it even comes with this little cool display. It seems like we finally have everything we need for this build. Now the question is how we are actually going to attach the power bank to the MagSafe. According to Apple's accessory design guidelines, MagSafe is basically an array of magnets plus a bunch of other specs. Hopefully, someone else already read all of that and designed this magnet array, so we can just use it. Let's quickly look at the MagSafe magnet array. The outer ring is north, the inner ring is south, and the single one magnet has a south center with north on each side. In phones or cases, these poles are reversed. That's why you'll find two types of magnets, the common case ones and the stronger charger type I bought, with opposite polarity. Now that we've got all the parts for our power bank, let's check out the custom case I designed. I made it as compact as possible, so every single component fits snugly inside. The coolest part? The two body pieces use a snap fit design. They simply click together with these tiny clips. You can print it on your own 3D printer, or order it cheaply from online 3D printing services like JLC. It's time to start assembling the power bank. The first part we'll work with is the wireless charger. As you can see, its wires are a bit too short to position the board properly, so I added two extra pieces of wire. Just make sure the wires you use are at least as thick as the coil's wire. And for safety, it's best to cover them with heat shrink tubing to prevent any short circuit. This capacitor is positioned where the board needs to sit, so we need to resolder it vertically to make room. The coil should be as close as possible to the phone for efficient fast charging. To keep it firmly in place, I designed this small printed washer. And to secure the PCB, you simply use 3 screws. Enjoying this build? Smash that like button and subscribe so you don't miss our next cool projects. Now it's time to place the power bank module. Before that, we need to connect the USB-A pins on the module to the USB-C breakout board. For our wireless charger, connect GND, D+, D-, and VCC. Just leave the middle pin unconnected. That's for certain fast charge protocols. Next, connect the USB-C breakout board to the wireless charger and secure the power bank with the screws. The USB-C port on the module is dual purpose. It both recharges the power bank and can be used to charge your phone. Before placing the batteries, we need to balance their voltage since we are going to connect them in parallel. If the voltages aren't the same, a large current will rush from a higher one to the lower one, which can be dangerous. The easiest way to do this is with the power bank module we are using. Just connect each battery separately to the power bank module and let it charge until it's full. Now that both are fully charged, we can connect them together. It's better to wrap the batteries together with heat shrink before placing them in the case. This keeps them steady and reduces the risk of damage from movement. The case keeps the batteries secure with its sidewalls and top cover. This power bank module also has an NTC sensor to monitor battery temperature. Place it close to the battery for accurate readings. Then connect the battery wires to these two pins on the module, soldering both negative wires together and both positive wires together. Be very careful, reversing the polarity can instantly damage the board. I also printed this small knob to place on the power button, making it easier to press. We can put the top cover on. We're done with this side. On the other side, we need to place the MagSafe magnet. Apply a small amount of glue to hold it in place. Make sure the magnet's orientation is correct. If it's reversed, the polarity will be wrong. The magnet needs to be as close as possible to the phone for maximum magnetic grip, so I printed these thin covers to protect the magnets while keeping the gap as small as possible. Our power bank is ready. But is it worth building and what's the final cost? First, let's see how the power bank works. Press the power button once to turn it on and double press it to turn it off. Another cool feature is that the power bank itself supports fast charging. When you plug it into a fast charging adapter, this green indicator turns on. But if you use a regular adapter, it stays off. That fast charge indicator isn't just for charging the power bank. It also lights up whenever your phone is fast charging on the power bank's wireless charger. And yes, it even works when you charge your phone with a cable. It can be used with Android phones too. You just need one of these MagSafe cases to attach the power bank to your phone. It supports most fast charging protocols for Android devices. You can also use it to charge any non-MagSafe accessories that support wireless charging. It works just as well. Now it's time to check the capacity results. I charged the iPhone 16 Pro Max twice from 20% to 80% with wireless charger, and the power bank still had 10% capacity left. With a wire connection, the results were even better. I could charge the iPhone 16 Pro Max 3 times from 20% to 80% using a cable. If you don't need that much capacity, you can make the power bank slimmer by using a single cell battery. Here's the final cost breakdown for this power bank. It comes to about $25 in total, nearly 4 times cheaper than the $99 iPhone Air MagSafe Battery. Our wireless charging speed goes up to 15 watts compared to Apple's 12 watts. We also get USB-C wire charging at 22.5 watts, while Apple's is limited to 7.5 watts. And of course, we build this with a 10,000 mAh capacity. Apple's is just 3100 mAh. Plus, we have a display that shows detailed information, unlike Apple's single LED. I designed this power bank with the smallest possible length and width, so it works with almost any phone size, whereas Apple's only fits the iPhone Air. Sure, the iPhone Air MagSafe battery is slimmer, but does it really justify that price? If you like DIY and phone accessories, I built a cool phone speaker case in this video. See you in the next one.